This is a question from the frequency response analysis, and here we are given the transfer function, the open loop transfer function g of s is equals to 1 minus s divided by 4 plus 2s. And here we are asked to find the number of encirclements of the Nyquist plot with respect to minus 1. As a standard approach, what we do is we will see the magnitude and the phase angle of this g of s for different values of the omega, and we observe the encirclements with respect to minus 1 graphically, and finally we can opt the corresponding option. What I do is, here g of s is equals to 1 minus s divided by 4 plus 2s. That means I can write in angle and magnitude form. I will get a magnitude of square root of 1 plus omega square divided by 16 plus 4 omega square at an angle minus tan inverse of omega minus tan inverse of omega by 2. I will make a table of different values of omega, and for different values of omega I will see magnitude and phase, and I will locate the points in the UV plane. In the UV plane I will see the graph, how does it comes. What I will get is first let us take a table for omega, for magnitude and phase. For omega, magnitude and phase. For omega equal to 0, if I substitute, I will get a magnitude of 1 by 4 at an angle 0 degrees. If I take for 1, I will get a value of around 3, or I will get a point of 0.3, that is going to be equal to minus 71.56 degrees. If I make a omega equal to 5, I will be getting around 0.4, same 0.4 and minus 145 degrees. If I take omega equal to infinity, I will be getting a value of 1 by 2 at an angle minus 180 degrees. If I see all these points, if I took a point discretely in a random fashion, what I get is I will see the points. I see the points in this Argand diagram. I see the points at 1 by 4, and the point of magnitude of 0.3 and minus 73 degrees, somewhere it may be here, and one more at omega equal, this is at omega equal to 1, and omega equal to 5, I will get minus 145 degrees, that means third quadrant, I will be getting some value at here. I will be at omega equal to infinity, I will be getting 1 by 2. If I take a continuous fraction of omega, if I change the value of the omega in continuously, what I will get is, I will get a pattern like this. And let us take this as minus 1. Okay, I will get a pattern like this. This is for omega equal to 0, omega equal to plus infinity. If I consider from omega equal to minus infinity to 0, which is nothing but which is symmetrical with respect to real axis, I will be getting like this. If I consider this minus 1, there is no encirclement with respect to minus 1 if you see the plot. That means I can say that option A is the only thing. There is zero encirclements of this transfer function with respect to minus 1 in the Nyquist plot. That's all.